Hello YouTube, RJ. Today we're back on the jukebox restoration. In the last video, as you know, we've got the mechanical selectomatic head working, at least as far as we can test. So we went and pulled the two modules, the audio amplifier and Cormac selection unit. We took those units off the door and I've got them here in the lab. I went through the manual and I figured out what capacitors would need to be replaced. And we went ahead and I got those on order and they've come in. So I've got the amplifier. I'm going to start on the amplifier. I got the amplifier up on the bench here. It's got some interesting something going on. We got some electrical tape here wrapped around these two capacitors. Not sure why that's that way or what that's doing. We'll look into that. I do notice we've got two 6BJ6 tubes missing over here. They're labeled XV102 and 107. I think these may be the AGC tubes, and I know from watching some videos and looking at manuals that some people pulled these out. These tubes were, the intent of these tubes were to kind of balance and level the audio equal, so loud records didn't play much louder, and then soft, it kind of balanced it with an automatic leveling system, and you can pull these tubes out and disable it, and I'm assuming that's what they've done. The tubes don't look, I don't see any markable damage to tubes, anything that pops out, any white or anything that would point out that you probably got a bad tube. I'm hoping the tubes are all good. I know this was playing the last time it was used many years ago. What I'm going to do now is I'm going to go ahead and pull tubes out, make some markings and pull some tubes out, get them out of my way, flip this thing over and take a look at the bottom of it and see just what kind of trouble I've got myself into. So let me get that done. Nothing to sit here and watch. Just going to put a little tape on tubes and mark which channel. Okay, I got the tubes out. Just wanted to point out that while I was looking the unit over and getting the tubes out and labeling them, what I found. I got a blown fuse. So this fuse right here, likely I do have a fuse for it. So that worked out. Anyway, I've replaced it. Here's the new fuse. Got a new fuse for it. We've popped that in when we get done, so I won't forget to change the fuse and wonder why it's not working. That's the first part that's got to get changed. Got all the tubes off. Thought I would show, if you can bear with me just a second here, thought I'd show what I did with the tubes. You might find this interesting, maybe not. I took a piece of foam, just plugged all the tubes in. I went ahead and labeled them anyway, but the numbers represent, like 101 here is 1, 102 is 2. So they're all labeled. I'm putting them on the other bench out of sight and out of mind while we do this. So we're ready to flip this thing over and see just what we have. So I'll be back and we can see just how bad it looks underneath in just a moment. Okay, curiosity got the best of me. Before I flip this over, even though I told you I was fixing to do that, I got to take this tape off and see what we got. Oh, that's nice. Somebody's done something here. They've put a capacitor on that had a strap that was supposed to strap somewhere, that, and they just, I guess, taped it to that. That's interesting. Okay, so we know people have been in here messing with stuff, so I guess I'll hang this side over the bench so this can hang in and sit on the transformers. So let's go ahead and do that while you're watching. Let's find out what it looks like underneath together. Give me just a second to get this turned and placed where I won't damage anything. And lo and behold, I'll adjust the camera a little here. Lo and behold, it's basically as bad as we figured. So, I mean, it looks just like what we thought we would find. It's looks all original. Someone replaced this cap at some point. So, all right, let me start looking at what I've got here, and maybe clean up a little bit and start considering line of attack on changing all these capacitors out. So I'll be back. All right, so first plan of attack is getting rid of this hanging on capacitor. This is what we're going to be replacing it with. Calls for a 90. 90 wasn't readily available in the right voltage and stuff. Reasonable. So I'm putting 100 in. Obviously, going up a little in capacitance is not an issue, especially when you're talking, something with a tolerance that would be within the same range. But a little bit of extra capacitor on filter is not going to hurt us at all. So what I'm going to do is I'm going to put it in the chassis, and then I'll cover the hole on top when I'm done. So we've got the negative marking of our capacitor here. And following this capacitor out, the negative of this capacitor runs up and connects here on this dodgy looking solder joint on this terminal here. It worries me a little bit. So what I'm going to do is I'm going to go in and I'm going to put the negative, solder the lead of the capacitor directly in there. And the positive comes up and hooks to this connection, which is a little dodgy looking itself, but I'll clean them up a little. I'm going to put it in just like this, where it's well under the cabinet. It's away from anything. There's no short issues. And that'll be supported in there perfectly fine. So that's what I'm fixing to do. How I'm going to do it is, we'll go ahead, and what I'm going to do is I think I'm going to I'm going to take and clip this out to start, to get me room to work in there easier. So we'll clip the red wire out. And let me get this black wire clipped out as clean as I can. Okay. Feed him out. Feed him out. This should fall right out then. And as I showed, I'm going to come in here and just do this right here. I'm going to go in and solder this in as so. And this will be our replacement, just like that. So I'll go ahead and get that soldered in. Okay, I've got that capacitor in. As you can see, it's well down under everything. It's actually just above the small transformer, pretty level with this transformer, well under our chassis. So we're good there. It's well supported. It's not going anywhere. So now I've got to tackle this other big electrolytic. This is that can cap. And so what I've got in mind is I'm going to take I'm not going to restuff this. What I'm going to do is I'm going to abandon this capacitor. This capacitor will be abandoned. What I'm going to do is I'm going to take a terminal strip. I'm going to go in here and use this nut for this transformer. I'm going to go in and I'm going to put this strip in here. Add this strip in and bring my grounds here, move these grounds here to here. And then I'm going to use the capacitor and the resistors I'm going to put on the terminal. So that's my plan. So that's going to take a little work. So I'll come back when I have that done. I just need to do tracing out of these resistors and where they connect, what wire they connect to, everything about this capacitor, which capacitors, which terminal. And then once I figure all that out, map it out on paper, I will put the terminal strip in, I'll rewire the whole thing back that way. So, okay, you can see I've got my terminal strip in over here, and I've replaced those 3 capacitors out of the can, left the can in place underneath. So we've abandoned this capacitor completely. The giant capacitor that was they had stuck hanging out of the hole and taped has been replaced with this Rubicon right here. So we've totally taken care of the filter capacitors over here, are taken care of. Then I came over here and started replacing capacitors. Some of these lovely rascals here. So anyway, I started replacing them with more modern capacitors here and here and here. Had 2 low voltage electrolytics that I changed here. And if you notice, what I do is I take these capacitors and I take a piece of shrink wrap, small shrink wrap, and I slide over it. And that's how I put them in, and that alleviates concerns about a short circuit. So that's how I'm doing these. It's very tedious and time consuming. You have to take your time. You have to make sure you don't cut anything else accidentally. You make sure you know which terminals are where. You got to watch with the electrolytics and make sure that you get the polarity correct. So I spend a lot of time. It's very slow and tedious for me because I go through the book and I find the capacitor, and then I make sure I find on the schematic and verify it's the right capacitor, that the value matches what I expect, and that it's going to where it is. And then I get that capacitor out and mark off the paper that I'm doing that one. I take it out, I put shrink wrap on, I put the new one in, get it soldered. Sometimes you run into this old solder, is nasty. Like, I don't know if you can make out right here. Let me try to bring the focus up a little bit to maybe where that'll show a little better. Right here. Had a hard time getting this capacitor to solder on here. Ended up taking my solder sucking gun and actually cleaning all the solder off here I could, fluxing it very heavily, heating it up, letting the flux do its business to get a good solder in there, because it's really, some of these solder joints are really nasty over the years. So it's a tedious job, and I'm just continuing on. I'm working my way across this amp, and we'll get there. This is not something you do in an hour. So I'll be back as I've made some more progress to show you how we're doing, and we'll pick it up from there. Okay, so here we are. I've got all of the caps changed out. I looked at this selenium rectifier. I thought about changing out to a silicone diode, but I got online and did a little research on it, and what I found was this thing is just a rectifier to bias some tubes, has almost no current through it whatsoever. And the old Seeburg guys on the old forum that repaired these for years said they've never seen one go bad. While these selenium rectifiers tended to go bad in high current uses, this thing is so lightly loaded that they've never seen one go bad. They've never had to replace one. So because of that, I left it in. I do have a little issue with this wire here. It's chafing a little, and I've kind of moved it a little, but I'm not happy. I think I'm going to do a little work there, maybe a little electrical tape around it where it's chafed. Now that I've got it moved better, hopefully that won't rub up against the selenium rectifier and chew. I don't know if you can make out clearly or not that the old insulation is chafing a little there. So it had got up to where the edge of this selenium rectifier was rubbing on it. So I'll take care of that, but then I'm going to pull this off the bench, and I've got that Tormac selector unit to put up here and do the same thing to. Luckily, it's not near as bad. So I'll be back in a minute after I get this taken care of and swap it all around. We'll look at this Tormac selector unit. So okay, here we are with the Tormac selector unit. It's a TSU1. So what I'm going to do now is I'm going to go ahead and mark and pull the tubes for this, and then I'll flip it over. We'll take a look underneath and see just how involved how involved recapping this is going to be. So give me a minute to pull these tubes, mark them, and I'll be right back. Okay, I got the tubes pulled out and marked. Went ahead and wiped them off and put some masking tape on them, put the numbers of the locations they plug into on it. And I flipped it over, and this is what I see. This looks a lot easier to recap than the previous one. This shouldn't take me too terrible long to do. So my plan is to knock out recapping this today, and then I'll clean it up a little bit and set it aside because I'm waiting on something else to come in before I can move ahead with this. And that'll be in the next one of the next videos coming up. You'll see what I'm waiting on and why I'm having to wait on it. So I'll go ahead and recap this, come back and let you see what it looked like. I'll probably do a segment here where I go through actually replacing one of these caps to give you an idea of exactly how I go about it. Everybody does it differently, but I'll show you how I go about it. So let me get all set up and get going, and at that point we'll come back and change out a capacitor. Okay, it's time to change some capacitors. Now, we're going to change this one right here. You probably can't read it, but it's 0.02 microfarad. And I've got my capacitor I'm going to replace it with. And if you notice the little dot right there, I went ahead and marked the full side. If you're not familiar with this, I'm going to have a video I put out shortly, but there's lots of them on the internet. These capacitors, when they're made, the outer full is hooked to one lead and the other is not. So to shield better the capacitor from noise, it's best to hook to the full. In fact, if you look at this capacitor right here, you'll notice there's a stripe on here. Now, these are non-polarized capacitors, so it doesn't matter which way you put it in from an electrical point of view. But when you're working with amplifiers that are very sensitive to noise, then there is a benefit to having the shield side out. So the old capacitor manufacturers used to mark this, and the new do not. And there's an easy way to check it with the oscilloscope. And I usually start these projects by taking all of my capacitors and marking the shield side. I just sit here and go through and put a dot, put a dot, put a dot, so that when I pull it out here, like I've got my dot here, I can tell which way is which. So this needs to go in this way. Now, will the end of the world happen if you do this? No. Some people say it's unnecessary and, you know, it's useless. Many tests have backed up that you do get more noise if you put it in the opposite way. Again, this only matters when you have very sensitive amplifiers where any induced noise is going to be amplified. Okay. But, you know, it can make a difference. So it's not that hard to do. So we'll put our capacitors in the right way. And, you know, if it doesn't matter, then it doesn't matter I'm doing it. Some people are going to argue and say, no, that's just stupid. You don't need to do it. The manufacturers would mark it if you needed to do it or whatever. Well, do it your way. You're not going to run into a problem likely, but I can point you to a number of tests where professional audio amplifier manufacturers have shown they've built amps with everything the wrong way and everything the right way, and the difference in the noise was pretty noticeable, especially under test. But so we're going to go ahead and put it in the right way. So how do I do this? Well, everybody has their way of doing things, but there is a few things that I've learned, and that is you want to avoid trying to solder to tube sockets if you possibly can. If you have to, do it, but if you can get away from it, don't. Even if you're going to terminal strips like over here, sometimes you're best not to mess with these terminals, and here's why. The old solder they used different rosin formulations. They degrade over time and become kind of a polluted thing. You get dirt and stuff on these things, and then you go to solder, and what you do is you bring up this black goo from the old rosin and dirt, and it can be difficult to get a good solder joint on sometimes. On the other hand, the leads coming off items on that terminal strip, which was soldered long ago, have a good connection, and they're not so polluted. They were plated well when they were manufactured, and they're not going to have all that rosin from the solder and stuff that's been on there for years and growing organically and such, because they used organic rosins, of course. So anytime I can, here's what I like to do. I like to go to the component itself and clip it as close to it as I can. Okay, now I've made note this capacitor and which direction it needs to go in, and I go up and I like to clip just as close. Now if I want to test this one for some reason, I flip my pliers to get a little spacing there to hook to. Okay, in this case I'm not going to test this, I'm just replacing it. So I'm going to clip it absolutely, turn my cutters, my little nippers, to where they're going to get up as close to that capacitor as I can. I'm going to clip it. I'm going to do the same thing here. And this is going to allow me to use the leads from this old capacitor to connect my new capacitor. That's going to give me a better chance of having a good solder joint and not having to mess with worried about damaging these sockets. So you say, okay, but you don't have anything to really solder to. Well, that's true. And if you get it at a bend like I did here, you might have to come back and clip it to get the bend out some. Or I prefer to take a pair of pliers and straighten that bend out a little bit. Let's see if we can straighten this a little bit. And you say, okay, why? Because I want to slide this insulation off of this. I'm going to take this insulation on the wire, and I think I'm going to bring you down closer so you can see better what I'm doing. It'd be a little more difficult for me, but maybe better for you guys. Let's see if we can refocus you in. Sorry about having to move your camera around so much. But what I'm going to do now is take these pliers, and I'm going to take this, get this bent straight, and I'm going to take this insulation off. Okay? Voila. This hard old insulation. You'd say, RJ, put some new heat shrink on there. No need to. It's not going to shrink down. Anything I've got is not going to shrink down that small anyway. I'm just going to simply take and clip a little bit of that off. And then I'm going to slide that right back on. And what that's going to do is give me enough to work with. And once we slide her back on, we will take and pliers and get her slid all the way back up there, leaving me a little to work with. And now what I'm going to do with that is I'm going to take and my pliers, and I usually like to take smooth needle nose, ones that don't have teeth. I usually like to take my smooth needle nose because it doesn't then crease this whole wire. And I grab it at the end and I start turning it. Okay. And what I'm going to do is I'm going to twist me a little hook here. You'll hear people say J hook. You know, people do the J hook. Okay. This is kind of the J hook. Like that. Now, if you can see, I've got a little hoop on that wire now. And that's where I can come in with my capacitor like this. I can do the same thing again, okay, and solder it, and bam, we got her in there, and we didn't mess with this socket, worrying about damaging it or causing a problem or getting the old solder worked up and making a mess that doesn't want to connect or whatever. So basically, I can take this wire and bend her back down a little bit, and I can decide that's about where I want my capacitor, say right there. So I'll just bend it a little, let me know where. Exactly where I want it. And then I take that and I say, okay, I'm going to do the same thing over here. So I need to bend this one about here. Right about here. I'll give me a little bend to let me know that that's about where I'm going to be doing that one. And I'm going to set that over to the side because I have to do the exact same thing with this one. We're going to straighten her out using my regular needle nose because the flat non-teeth needle nose will just slip if you try to do this with them. I'm going to straighten this out so that I can get the, because I don't want to give up any of that wire I have to work with. I'm going to try sliding him off. Might have to straighten him a little more. So you can see that, you know, and I'm probably not the fastest person in the world working on this stuff. I will be honest with you. But you know, this is a method that I go through to do this. And this one's fighting me for some reason. Insulation doesn't want to come off. There we go. We're getting her. Okay, get my insulation off. Maybe. Sometimes rotating it helps. There we go. Okay, now, again, just going to cut me a little off to give me enough room to work with. You could probably get away with no insulation on this one, but, you know, I like to keep things insulated. When I put them in where I'm going to have long runs, I often put shrink wrap on them myself to keep from having shorts. If I'm near anything else, this insulation is a little messed up on the end. They got it hot when they soldered, and so it's hard. Doesn't want to go in. It likes that way better. So now we're going to put a J-hook just like we did on the other. So I'm going to grab my correct pliers. And I'm going to do the same thing again. I'm going to put me a little J-hook here. And I try to support, if it's hooked to something over here, I try to support it a little. A little something on the pliers there. Okay, there we are. So now we need to get these in. So what I like to do is go ahead and cut all this excess off. It's going to fight me. We'll make this thing a little shorter. Leave a little on there because we got to bend it. Make it a little shorter for me. And I don't get in a hurry with this stuff. As I said, I'm not the fastest you'll ever see doing this kind of stuff. I don't try to get in a big hurry. To me, a lot of it's about the journey. And this hoop, if I've turn it a little, turn it this way a little bit, it's going to make my life a lot easier. Just like that. So, making sure my dot's the right way. And I left that one open a little bit intentionally. So now we come in here and we bend our capacitor around this as such. It can be fiddly sometimes. You don't have a lot of room. Turn that up like that. And the reason is because I'm going to clip it. I don't want these tails. So that's that one. I'm going to do the same thing with this one. We're going to get the soldering iron out. And we're going to solder her in there. Now you notice I left this one a little open. I didn't close it up as tight. That's because I needed to get this in. So we'll go ahead and get this bent around. Camera's in my way, so it's making it a little. What you don't realize is that camera's so close. I'm having to fight to not hit the camera. I'm not as free as I normally am to move around. Clip her off nice, and then let's go ahead and close this one up a little bit. Come in from the side on this one, so I can't stand my pliers straight up. And there you go. Now all it's going to take is a little bit of solder to have that one done. So let's grab our soldering iron or solder. I'll apologize for the extraction fan noise, but let's go ahead and solder this up. Okay, that's it. We've just replaced a capacitor. It's really no different for any of the others. There's all kinds of challenges you're going to run into doing this. Every capacitor is different, obviously, and how much room you have to work with. Some of them you have to take components loose. That's a challenge because if you don't have any extra lead to work with and you clip it loose. And so what I do with that is, for example, let me bring you over here to show you a different one. Let's come over here and look at this one right here. See this wonderful one in here? See how it's all covered with things? Okay. If I can easily grabbing both leads with pliers and bend this resistor up, because you don't want to put any load on this carbon composite resistor or she's going to break. Ease her up out of my way. That's great. But sometimes I would need to get this out of the way. So what I would do is, if I get one that's absolutely in the way. There's no way to get to. What I do is I come in and I do the same thing, but I do it the opposite way. I click as tight up against the terminal here as I can. You just have to make sure you have enough lead to get back to that terminal to get a solder joint. And again, remember, these solder joints can be a challenge when you do that. So what I do is when I have to do that, I clean them good. I put a little bit of flux, not a little bit, I put quite a bit of flux over the area. I heat it without any solder and let the flux cook off and clean, and then I go back to solder. And so usually you might have to do this 2-3 times to get a good solder joint, but usually that'll get you. You'll get in there and that'll get that done. So I'm going to get to doing the rest of these capacitors without the camera in my way. And we're back. And I've got all the capacitors changed out on this unit. This little square capacitor, I just fit it between the prongs of the old capacitor. Then when this resistor and wire was soldered up here, it pretty well holds it in place. But to make it a little secure, they recommended that you glue it, epoxy it in or something. I didn't want to epoxy. I used a little hot glue so that if I ever need to take it loose, nothing gets hot in that area. And if I ever need to take it off, I can peel it out of there and do what I need to. But so that replaces the big metal can capacitor that I've left in place to have it fill the hole and look original, but there is no connections to it of any kind. One of the other things I noticed is I put some new electrical tape right here because this electrical tape was peeling off. And then I got to thinking, why are they wiring two different types of wires? And then I got to looking, this is a fuse holder. It's busted. And I figured out what was wrong with that fuse holder. Turns out this fuse is wedged into this thing. This is the wrong size and length fuse. Somebody put the wrong fuse in there, tried to tighten it in and broke the end off this fuse holder. So I'm going to see what I can come up with to do about that. I mean, if I can't get one to go in that place, I'm at the very minimum, I'm going to put a inline in this wire and we can just tape it down or whatever, or tie wrap it down, do whatever we need to. But I'm going to get a fuse in this line before I'm done. I don't like the idea of that not being fused. That's not the way to repair things. So with that, we're done recapping this. Now I'm going to be testing tubes, seeing where we are with tubes, and you know, testing some power up stuff to see where we are with that. So I'll catch you in the next video in this series, and we'll keep moving forward with this. Thank you for being along for the ride with me. Hope you enjoyed it. Hope you learned something. And I hope I can get you to subscribe to my channel if you haven't done that. I need all the subscribes I can get to help me out. If you hit like and hit the notification bell, that's a big help also. None of this costs you anything, and you can always undo it later if you just change your mind. So catch you later.